Welcome students for the chemistry lecture B.Sc.II and now in this lecture you are going to learn and understand the surface chemistry. Here up till now we completed the discussion of two topics. The first topic, it is the electrolytic conductivity, and the second unit, that is the physical properties of liquid. You have studied these two topics, and let us begin with the third topic, third unit, surface chemistry. Here all of you know the study of surface chemistry, it is the study of the phenomenon that occurs at the surface. And you know, the process of adsorption, the process of absorption, the catalysis, etc. These are some processes that takes place at the surface, and the phenomenon which occurs at the surface, it is studied in the surface chemistry. Then in this chapter you are going to learn the introductory part of the surface chemistry, then how the adsorption takes place and what is the mechanism behind the adsorption phenomenon, then the demonstration of adsorption with the help of PPT, then the definitions of some important basic terms, then the distinction between adsorption and absorption, characteristics of adsorption, factors affecting adsorption, types of adsorption, distinction between physical and chemical adsorption, adsorption isotherms, and for your study there are two adsorption isotherms. The first one is Friendlich adsorption isotherm, and the second Langmuir adsorption isotherm. And at the last you are going to learn the types of physical adsorption isotherms and applications of adsorption. These are the subpoints that you are going to learn in this unit, surface chemistry. So the introduction of surface chemistry. Here surface chemistry is the study of surfaces that occur at the interface of two bulk phases. And here the bulk phases can be of the following types as solid gas phase, liquid liquid phase, solid liquid phase, and liquid gas phase. That means when a solid and gas, these two are the bulk phases, and at the surface of these two phases the phenomenon of adsorption occurs. And what is the mechanism behind this? What is the adsorption? What is the absorption? Then the basic terms that are oftenly used in the study of adsorption, we see one by one. Here adsorption, it is nothing but the accumulation or collection or adhesion of atoms, ions, or biomolecules or molecules like gas, liquid, or dissolved solids on a surface molecule. Remember, adsorption, it is the collection or accumulation of one molecule on the another molecule, while the process of absorption, it is a physical process, and the absorbing substance. It gets penetrates into the another substance, while the adsorption, it takes place at the surface only. Here this picture, it clearly shows the process of adsorption. This is our activated charcoal, and these are the gas molecules. These gas molecules, they are gathered, they are accumulated, they are aggregated on the surface of the activated charcoal. They cannot get penetrated into the charcoal. This process, it is called as adsorption. The collection or accumulation of the one substance, here gas molecules, on a activated charcoal. That means this activated charcoal is a solid phase and this one is a gaseous phase. Then we deal with the process of absorption. Suppose these are the foreign particles and this is the absorbing medium. These foreign particles, they get absorbed into the absorbing medium. Here the substance which get accumulate on the surface of the another substance, it is called as adsorbate, and the substance on which adsorption occurs, it is called as adsorbent. While the process of absorption, it is the partition. Here suppose let we have, this is phase 1 and this is phase 2. The phase 1 molecules, they get penetrated into the phase 2 and this process, it is our absorption, while adsorption, it occurs at the surface only. Here adsorbate, it is the material being adsorbed on the surface. It is called as adsorbate. Then adsorbent, it is the material on which adsorption takes place or material doing the adsorbing process, adsorbing phenomenon. It is called as adsorbent. In the previous example, as you have seen, the gas molecules, they are adsorbate and activated charcoal, it is a adsorbent. Then there are two types of adsorption. First one is the physical adsorption, and physical adsorption, it occurs due to the van der Waals attraction forces between adsorbate and adsorbent. And the chemical adsorption, this is the chemical bonding between adsorbent and adsorbate. We see in detail later on. Then there are two types of adsorption depending on nature of attractive forces existing between the adsorbate and adsorbent. Here adsorption can be classified as physical adsorption and chemical adsorption. Then we see distinguishing points or a difference between physical adsorption and chemical adsorption. The physical adsorption is also called as physisorption and chemical adsorption is also called as chemisorption. Then the first difference between physisorption and chemisorption is the forces of attraction are van der Waals forces, and here in chemisorption the forces of attraction are chemical bond or chemical attraction. Then in this physisorption, low enthalpy of adsorption, and it is in the range 20 to 40 kilojoule per mole. That means enthalpy of adsorption means while the adsorption of any material takes place on the surface of the another material, at the time of adsorption process the heat is evolved, and that heat evolved is called as enthalpy of adsorption. And in case of physisorption the enthalpy of adsorption is a very low, it is in between 20 to 40 kilojoule per mole. In case of chemisorption, there is a high enthalpy of adsorption and it is above 80 to 100 kilojoule per mole. Then this process is observed under conditions of low temperature, and opposite of this it takes place at high temperatures. Then the chemisorption is specific one or highly selective one, and the physisorption it is not specific. In case of physisorption a multi-molecular layer may be formed, and in case of chemisorption generally a monomolecular layer is formed. Then the another distinguishing point, physisorption is a general phenomenon and occurs in any solid or fluid or gas, solid gas systems. And chemisorption it takes place either in solid liquid, gas solid, solid gas, whatever. Then in physisorption, perturbation of electronic states of adsorbent are minimal, and here the states are maximum. Then the typical binding energy of physisorption it is about 10 to 100 mega electron volt, and in this chemisorption the binding energy is about 100 mega electron volt. Then the elementary step in physisorption from gas phase does not involve an activation energy, and here the chemisorption this process it involves the activation of energy. Then for physisorption under appropriate conditions gas phase molecules can form multimolecular adsorption layer, and here unimolecular adsorption layer will be formed. Then before going to applications of adsorption we see the basic points, and these are here. Adsorption it is a surface phenomenon. Then the accumulation of molecular species at the surface rather than in the bulk of solid or liquid is termed as adsorption. Then adsorption it is a surface phenomenon. Remember well, the concentration of adsorbate increases only at the surface of adsorbent. Then the definition of adsorbate here, it is the substance which is being adsorbed on the surface of another substance. I repeat, adsorbate it is the substance which is being adsorbed on the surface of another substance. Then adsorbent, it is the substance present in bulk on surface of which adsorption is taking place. For example, suppose the adsorption of acetic acid, it takes place on a charcoal powder. That means in this case the acetic acid is a adsorbate and charcoal powder it is a adsorbent. Or and in another example, the adsorption of gas molecules uh, on any metal, then a metal it acts as a adsorbent and the gas molecules they acts as a adsorbate. Then the next term that is oftenly used in the study of adsorption, it is the desorption. And desorption, it is the process of removing an adsorbed substance from a surface on which it is adsorbed. Simply, the removal of adsorbed substance from the adsorbent, it is called as desorption. Then we see in detail what is the absorption. This absorption phenomenon, it takes place in the bulk of the substance. Here it is the phenomenon in which a substance is uniformly distributed throughout the bulk of the solid. Suppose, for example, we have a chalk stick and you pour a ink on it. Then what happens? The ink, it will get penetrated in the chalk, in the bulk of the chalk, and that process it is the absorption. In another example, suppose we have a sponge and we pour a 2 spoon of water. Then what happens? The water it will get penetrated on the in in the bulk of the sponge. That means the water molecules they get penetrated in the bulk of the sponge, in the cavities of the sponge, and this phenomenon it is the absorption. Remember, absorption it is a bulk phenomenon. The concentration is uniform throughout the bulk of the solid. Then the sorption. Here next term it is the sorption. Sorption, when adsorption and absorption take place simultaneously, it is called as sorption. Remember, when adsorption and absorption take place simultaneously, it is called as sorption. Then we repeat here, enthalpy or heat of adsorption. Adsorption occurs with a release in energy, or adsorption occurs with evolution of energy. That is, adsorption is exothermic in nature. The enthalpy change for the adsorption of one molecule on an adsorbate on the surface of adsorbent is called enthalpy of adsorption or heat of adsorption. Then the types of adsorption. As already I have told you, there are different types of adsorption, namely physical adsorption and chemical adsorption. Here, the physical adsorption, the characteristics of physical adsorption. If the adsorbate is held on surface of adsorbent by weak van der Waals forces, the adsorption is called physical adsorption or physisorption. Remember, the physical adsorption. It is also called as physisorption, and in this physisorption, the adsorbate is held on a surface of adsorbent by weak van der Waals forces, and it is the physisorption. Then physisorption, it is not specific, it is reversible. The amount of gas depends upon the nature of gas. That is, easily liquefiable gases like NH3, CO2 gas adsorbed or to a greater extent than hydrogen and helium. Remember, easily liquefiable gases, they get adsorbed in greater extent than H2, hydrogen and helium. Higher the critical temperature of gas, more will be the extent of adsorption. Remember. Then the extent of adsorption increases with increase in surface area. That is, for example, the porous and finely divided metals are good adsorbents. Then there are weak van der Waals forces of attraction between adsorbate and adsorbent. Then it has a low enthalpy of adsorption, and it is in the range 20 to 40 kilojoule per mole. For physisorption, low temperature is favorable. No appreciable activation energy is needed, and it forms multi-molecular layers. These are the some points which you should remember regarding the physisorption. Then that means physical adsorption. Then we see little bit regarding the chemical adsorption or chemisorption. The first point you should remember that if the forces holding the adsorbate and adsorbent are strong, as in chemical bonds, the adsorption process is known as chemical adsorption. Here, when the forces holding adsorbate and adsorbent, they are strong as in chemical bonds, then that adsorption process is known as chemical adsorption, or simply you can say that chemisorption. Then the second point, chemisorption, it is a highly specific, it is irreversible. The amount of gas adsorbed is not related to the critical temperature of the gas. It increases with increase in surface area. There is strong force of attraction similar to chemical bond. Then it has an enthalpy, heat of adsorption. It lies above the 180 to 240 kilojoule per mole. High temperature is favorable, high activation energy needed, and remember, it forms a unimolecular layer. Then for next lecture we will see the factors affecting adsorption of gases on solids. हाँ